Alright, you guys, question number 5 on the review. For each equation below, find all discontinuities algebraically, describe them in words, and find the domain and range and interval notation. So if you remember what we're looking for, let's just start off with A over here, okay? What we're looking for is that in this particular case, the denominator cannot be equal to 0, correct? So let's start off with just solving that. So currently the denominator is x squared plus 2x minus 3. If we factor this, we should get x minus 1 and times x plus 3. Okay, I believe that'll give us what we have up here. And in this case, it's easy to see that x, if this was going to be 0, our actual solutions are x equals positive 1 and x equals negative 3, because both of these numbers make this equation equal to 0, which is how we find the solution. However, if it's in a rational function on the denominator, they cannot be. These then become vertical asymptotes. So we have our two vertical asymptotes. We have vertical asymptotes at, okay, and you can write this would be kind of like describe it in words. You have vertical asymptotes at x equals positive 1 and x equals negative 3. Although what you see when you graph it, so we can actually write these out, is that x plus 1 is an extraneous solution because it actually shows up on the graph but doesn't work in the function. So we're just going to be writing limit notation with this x equals negative 3, okay? And the way we are going to do that, let's see, I graphed this for you. Let's see if we can find that. Here we go. So this is the vertical asymptote here at, let's see if I can work this over here, at negative 3 right here, okay? This should be the vertical asymptote. So as you can see, if we are approaching, we're going to approach it from two directions. We're approaching negative 3 from the right-hand side, and we can also, on the same one, approach negative 3 from the left-hand side. And the way we're going to write that is going to be the limit of f of x as x approaches negative 3. Let's just start from the small side, from the left-hand side. Okay, and if we do that, it's going to go to negative infinity. Okay, so that's this one right here. Let me see. Let me try one more. See if I can highlight this here. Okay, here we go. If we're approaching it this way, okay, whoops, it goes down to the negative side, okay? Then we also, the limit of f of x as x approaches negative 3, but this time from the right-hand side, so from the positive side. So if we're coming from the positive side, okay, from the positive, our limit or our intended height of this function is going to be positive infinity, okay? And that's what it means by writing it in limit notation, those two. Now we also have one more. We actually have here, we have a horizontal asymptote at y equals 0, and I'm going to ask you guys to go back and review that from one of your chapter 1 tests online. I have videos on that, because there was that little, or maybe it was the chapter 2 test, there was that little rule where you look at the I'm sorry you guys, I can't think off the top of my head, but the number here on the denominator, okay, and then the number on the numerator, and if the numerator is smaller than the degree is smaller on the numerator than on the denominator, then the vertical asymptote is going to be 0. So in this case, we have the actual, horizontal asymptote is equal to 0. in this case. So that leaves us, we have one more thing we need to do, and that is to write the domain and the range. So I'm going to get rid of this. Okay, the domain and the range in, what is it asking us for? Let's go back. Interval notation. So after all of that work we did with our vertical asymptotes, but let's just use that -3 and the -1, even though it's just a whole. We're going to have the domain here. Let's see, domain equal to, right? And that's gonna be, let's see, we start off with -infinity to -3 union, right? And it's not going to be -3, that's why it's round, -3 to +1 union +1 to +infinity. And our range, now we have to take into account that horizontal asymptote here, and here's the vertical asymptote. We're going to go from, let's see, let me go back to that graph. From -infinity to 0, but not 0, union with 0 to +infinity. Okay, so having all of those, and this is just for 5A, will give you your solutions here. And one more thing on this, if you, I know a lot of you use this Desmos, and I think, let's see if I found, let's turn this off. Stop drawing. Cool. Now, if you go up and you want to check the table for this one, let's see. You can, I have it right there, the table. Here's your -3. When x is -3, it's undefined, and when x is +1, it's undefined. But as you can see in the graph, that +1, there's not even a hole there. That's what makes it extraneous. So just be careful when you're solving things algebraically versus what they're really going to look like on the graph.